Hi there, welcome back to another one of my videos. In this video, we're not going to go over all the stuff to do with fundamental particles because I'll do a separate video on that. But this is just an example question that you might get in a A22 past paper or in a paper involving fundamental particles. So here we've got a reaction where we have our anti-electron neutrino. It's anti because it's got the bar over the top, plus a proton goes to a neutron and some other particle that we don't know anything about. So we want to find out what that particle is exactly. So there's a few things we can do to go about finding that. So we know that in an equation or in a reaction, charge has to be conserved. So if we look at charge first, electron neutrinos or neutrinos in general don't have a charge. So I always write it out like an equation almost. So then we do plus a proton has a charge of 1. So that means on this side of the equation, we've got a total charge of 1, and that has to be balanced on this side. So a neutron we know has no charge. And then this particle, we don't know what its charge is. I'm just going to put it as, actually, I'll put it as small c. So we'll just leave that for now like that. Then we look at the baryon number. Baryon number also has to be conserved. Neutrinos aren't baryons, so they've got a baryon number of 0. A proton is a baryon, so it has a baryon number of 1. Remember, all baryons have a baryon number of 1, and all antibaryons have a baryon number of -1. And then we go over to this side, and N. Neutron is a baryon, so it's got a baryon number of 1, and then I'm going to put in small b here for the baryon number of this thing here. And then finally, lepton number also has to be conserved. So electron or neutrinos have a lepton number of 1, so therefore an anti-electron neutrino has a lepton number of -1. Protons aren't leptons, so they've got a lepton number of 0. Neutrons aren't leptons either, so they've got a lepton number of 0. And then small l will be our lepton number of this guy here. So if we look at X then, so its charge, there's a charge of 1 on this side. That's 0 plus, then that has to be 1 to conserve the charges. So it has to have a charge of +1. It's a baryon number. There's 1 on this side and there's already 1 on this side. So the baryon number just has to be 0. So we know it's not a baryon. And then lepton number, we've got -1 on this side and we've got 0 on this side at the moment. So our lepton number has to be -1. So from this, you know that it's not a baryon. It is a lepton, but it's an anti-lepton because it's got a lepton number of -1. But it does have a charge. Neutrinos don't have charges, so it can't be a neutrino. So therefore, we go, okay, well, I'm going to say it's an electron. But then is it a positive electron or a negative electron? Well, it has to be a positive electron. So you can either write that, it's called a positron, or an anti-electron. So you can either write it like that, or sometimes you might see it written like that with the bar over the top. But that covers all our stuff then, because it's a anti-lepton, so it has a lepton number of -1, and it's got a charge of +1, and it's not got a baryon number. So that would balance our equation here. So this is how I lay out all of these ones, is I laid out charge, baryon number, lepton number, so that you can clearly see what's going on at each point. So thank you for watching. I hope this has helped, and good luck with your questions.